Hello everyone, welcome to the overview of the MLOPS project. This MLOPS project is building a health disease classifier based on random forest and logistic regression models. And the core idea is to implement MLOps in this project using end-to-end model development, CI/CD, and production development things. And if you see the project structure looks like this. We have all the uh, code, the deployment scripts, the notebook scripts, the source scripts, the helper scripts, tests, and everything very well structured in their own directories. And then at the root directory we have some readme files, for example the mlops assign one. So this gives you an overview of what is the assignment all about, what are the tasks that we need to do, what are the data set, what is the problem statement, etc. And what we are going to implement, uh, and so on. Okay. So this was the problem statement, and we have overviewed this and we explained. And now we move to the readme, which explains you of how this project look like and what we have done. So it is a MLOps heart disease prediction project. The project structure look like this. It has description of all the directory, the base directory that is there, and then the setup structures, how you can clone the repository, how you can create the virtual environment, install requirements file, as so on, and the task progress. So we captured our task progress, and we captured activities under the task that we did. So for example, in EDA we do data cleaning utilities, EDA notebook with visualizations, and yeah, execute, log it to MLOps, MLflow, and so sort of thing. Then feature engineering, we analyze the data, clean the data, pre-processes the data, created features out of it, and we use DVC pipeline integration and DVC for data versioning, so that we don't have to keep the data or large data sets as part of Git repositories. Then the model training. So we started with the very basic scripts, just without any logging. We created two model in that, but ultimately we uh, enveloped all this training code into a ML flow tracking experiments and everything, and yeah, and so on. And then we have specified what are the cross validation that we have used, what are the metrics that we have used, and all these things. And after the model evaluation, what is the accuracy, and we are getting what is the best model that we choose. And as we said, for experiment tracking we are using ML flow. For model packaging we are using ML flow, DVC together to keep everything glued, uh, and we are saving the serialized models. And then the CI/CD pipeline, which can be used for automated testing and deployments to the cloud if needed. And then the model containerizer, for example, if you want to do automated deployment uh, to the cloud and anywhere, you need to containerize your models, provide some web APIs which can perform those activity, provide you with the results that are needed based on those tasks that are there. And then for production deployment, we chose local Kubernetes deployment with 2 replicas. And yeah, and for monitoring and logging, so as we said, like we have a metrics API in our container which logs all the calls, how the predictions are going, each and every request it logs it. And then we can use the log analysis script to analyze those logs directly, and it gives you a very good detailed description of what are the logs which are generated. And then for the documentation, we can see the final report.md, which is a markdown which has each and every detailed documentation about what are the tasks with the architecture, and it even has the screenshots of the actual working thing. Okay. So yeah, and now uh, going towards the end of this file. So this is the overview of what we did. Now I will show you some part of the code. So for example, the docs exist here. So this is how the final uh, report looks like. So we have all the tasks that we completed, what were the results, then we have some plots as well captured within. And then if we scroll down, so these are all the EDA charts which you see here, feature distributions and categories, and then the target distributions over what are the targets which we have percentage wise and count wise, etc. And then in the feature engineering, what we did was we used DVC orchestration to create the features and to log, create multiple files, and also create versions of them. And then uh, we used the same DVC for orchestration of this whole process. So for example, downloading the raw data, cleaning the data, feature engineering, training the model, and registering the model at the end. Okay. Then comes your confusion matrix of the trained model uh, uh, that we have logged here, then the ROC curve, so you can see how the model is performing and all those things. And then the experiment tracking. So we are doing local MLflow tracking for all the experiments that we did. We even logged the data assets like the DVC version that we are using, and even the models which are trained and are registered within the model registry or MLflow. So this provides the whole end-to-end uh, provision. And now you can see some screenshots where you have the MLflow dashboards and everything. So this document provides you very good idea of what we have done. These are some so if I move to, let's say, production deployment, so these are the Kubernetes logs that we did, and we ran two parallel replica of this thing. And then again, yeah, monitoring and logging. So these are some things. Now I will move to the actual uh, uh, component. So for example, for DVC, we have the DVC dashboard here which can show your experiment. So whenever we run a DVC pipeline or reproducible pipeline, it captures it as experiments with a particular git hash and everything, and it captures everything. So for example, whatever we have given the input output, so data CSVs, it captures their hashes, raw data, then your source as well, so the source scripts that you are using for these pipeline steps, and then the model metrics that we are, and which type of model, which model we have trained. So random forest was good, so we logged it. We are using it for deployment and so on. So, and it uses these hash comparisons to decide if there is any change in the data or in the source or anything, and then accordingly it sees that is it a new run or is it a same run or something like that. And these hashes are very important to keep track of everything going forward. Okay. And if I move to the MLflow now, so for example, all the experiment that we did, so as I said, we are even capturing the EDA in our MLflow experiment. So if I go to this experiment, we capture all the EDA analysis runs, and if I open, we capture some of the important parameters that we analyzed in our EDA step. So these are some of the important so for example, for each feature, what is the standard deviation, what is the mean, and all those things. And then we also capture artifacts. So for example, all the plots that we created are captured here. So even the plots can be linked to a particular EDA run and then reanalyzed further. So as you see, so these are the feature blocks plot and so on. Now if I go back to the home page, go to the experiments. Now the same MLflow experiments are used to track the training experiments as well. So we have to open this training experiments, and you see all the runs or model training of logistic regression, random forest, multiple iteration, and all these things are here. And you can basically see what are the experiments that you ran within this one. then you have the models. So for example, if let's say you trained 5, 10, whatever models in this, all these are tracked. So for if I go to models, you see the models which are tracked, which logged from which script, what is the source run, and if the model was registered into the model registry or not. Okay, because we are using a threshold based model registration. So if the accuracy threshold is below certain amount, or to be specific 80% in our case, then the model will not be registered into the model registry itself. Okay, now going back to the home page. Now here on the home page itself, we have a model section which captures all the models. They are not experiment specific. So if you see these two, these are the registered model from those experiments. So for example, if we ran 10 experiments and if we only found out that 2 of them were above the threshold, so we registered them. Now you can see the logistic segregation 1 and 2 are registered, and you can find out the specific run which generated. So if I click on this, you can see source run and all these things, inputs, detail, the description and everything. And now from here we can promote the model whichever we feel fit to be deployed to production. And here you see this is the production model which we have. So heart disease classifier, and this is not a new model that we train. It is just a model which were already trained and published to the registry, and then we promoted it to the production. So for example, version 1, now version 1 of this actually points to the heart disease random forest. So this is the random forest v2 model which is there. It is just a copy of that, but promoted to production so that it can be extracted and used in your deployments. And we have the relevant tags also here. And whenever we want to come or analyze any traceability, so we can just come to the production model. So let's say if we are running version 1, we want to see what were the training scenarios parameters. So we just have to go to the source run, it automatically captures it, and you can see what are all the parameters here. You see what is the data version, so you can see the training feature, the test feature, and even the tags of the dvc hashes, so we can recreate everything. Okay, and then if we go to artifacts, it also shows you the ROC curve of the model that you are running, the feature importance, how it trained and everything. Even the classification report is here, the F score, the precision and everything for each type of category. Then going back, uh, once the model is promoted to production, uh, what we do, we create a Docker image for local testing. But if you see this Docker image extracts the model with that particular name. So for example, it does not access the logistic regression or random forest, but it is going to always extract the model which is there with the production name and tags, and it is going to copy this model to the Docker image. It is going to copy the our fast API app and everything, and then we are going to deploy it in the Docker image for local testing. And I can show you, and even the current Docker image is running right now. I have already built the Docker image and it is up and running, and we can quickly run the test uh, script of that. So if I go here, if I go test deployment, so I have deployed. Now I have created a very basic payload section, and then uh, I have here some of the endpoint configurations what we need to configure. And then if I just, let's say, run this, let me expand it, and if you see, yeah, so the testing the Docker at this particular URL at this API, and yeah, we received this prediction. We can even see, yeah, model version which we are using is production in this Docker image. And then the same Docker image is used to publish to cloud if we want, using Kubernetes, and then it can run multiple parallel clusters for a very high intensive environment. Okay, and the API which is running in the Docker image, we can see its documentation here as well. So for example, the heart disease prediction API, we have the health API which shows you the health of the uh, service. So if I click here, if I execute, you see it is healthy, the name of the model which is deployed, from which stage it is deployed, and all these things. Then you have the metrics. So since I restarted the Docker recently, see all these metrics and logs are captured. So how many total requests came in, how many predictions, how many disease predicted, how many no disease, and all these things are here. And similarly, the main API, which is the predict API, which actually predicts the value. So this is the input. If I click on try out, execute, and you see this is the curl request, like what we sent, and this is the response that we got. And as soon as we run this, if I go back to my metrics, you see 4422. If I just execute it again, you see new requests increased, total prediction, because every time I run anything on the documentation itself is also an API. So that is why the total request increased. But you see the total prediction that were generated, what is the uptime of this Docker image, and everything is here. And at the end, now when we want to move to a cloud environment, we have also implemented a CI/CD GitHub action for this, and I can show you some of the checks that it does. So for example, if I go to MLOPS CI/CD pipeline, and you see there are multiple level of checks that we have. So first check is the linting check. If I go here, and we intentionally put uh, a basic formatting error which did not fail the script itself, but it had a format issue which is not up to the standard. So it stopped the deployment or the whole CI/CD pipeline at the first stage. So all these next steps needs to be uh, cancelled. So this is something, and at the end, the pipeline summary, it runs irrespective of your uh, and it shows you which stage, what are the results, and what are skipped, and everything, so on. So this is the whole overview of what we have implemented uh, for our MLOps project. And all these things are very easy to reproduce because we are capturing everything using MLflow and so on. So this is the basic overview of our project.